Hey there, good afternoon, good evening. Hello. How's it going? Happy Tuesday night. Wow, weird time to be streaming for me, but I am excited. So let's get to work. I forgot Spotify. Spotify. Yeah, I don't know, I'm feeling pretty motivated this week. Like I kind of wanted to do one weeknight stream this week and I realized I have Friday off work now, so I'll be streaming on Friday as well, most likely. So, what do I want to listen to today? Let's go back to that. Sounds pretty good. Let's see here. So, P. Lightsler, thank you for the follow. I appreciate that. Nice to see you here. Welcome. Age of Empires 2 stream? Absolutely not. I'm pretty bad at Age of Empires. I do my best, but it's a lot more fun for me to watch my friend get tilted in ranked matches. So, does this say Stardew Valley stream? No. Maybe, nah, probably not. Probably not. I don't really like playing games on stream. I don't know. It's not really the same for me, you know? Like, I know that it's like, why people usually do Twitch, right? But for me, I feel like it's just more stressful. Looks like you follow. Yeah, I did that. I was like, oh, I forgot my alt account was not following. Yeah, and that way I can see when the Twitch live notifications go too. So why not? Are we hacking Facebook today? No, God no. I'm sure somebody will ask though. There's always somebody. There's always somebody in Twitch chat who is looking for some programming streamer to say, hey, can you help me hack my mom's Facebook or something silly, Maybe I can convince Matt to add a netlink interface to my keyboard's MIDI player. Is it a kernel module? I mean, doing this from the kernel side could be pretty interesting. All right, where are we at? Let's see. So, kind of where we're at the moment is we started working on this link modes stuff, and there's all this. Let's see here. ethtool netlink. There's a couple of things I want to look at. So, the extended acknowledgement stuff is definitely something. I actually ran into this at work today. Extended acknowledgement, extended EC. So, apparently netlink, this is something that my library supports the option to set, but I don't think I actually allow parsing the data. So with netlink interfaces, if there is more detailed error information and you turn on this extended EC thing, you can actually get more info. And apparently ethtool supports that, which would be pretty nice. So that is something I would like to do at some point. I don't know how much work that's going to be. And in addition, we also have the this bit sets stuff. I still haven't really read this, but so we have what look like nested attributes with a flag, only a list, number of significant bits, the bitmap of bit values, and the bitmap of valid bits. I guess I could at least like read about this really quick and just like decide if this is something we want to do, because what we did last stream, basically, I'll show you while we're at. So, for example, for these things like the link modes here for Ethernet interfaces, we have our link modes and the peer link modes. This is what they advertise. So the way this works is we have a nested set of attributes, which is then a netlink array. So we iterate through it and gather another nested set of attributes, and then we look at just the index, and then we get yet another nested set of attributes. So I think at this point we're nested like 4 deep. And finally, within here, we can actually parse out the individual values, such as the index and name of an advertised link mode, and then look for errors independent to the slice. So this works, but it's just a lot, and I guess that there is a compact format, which would be potentially less work, but I don't know. I mean, I feel like the compact format is, I think Taryn mentioned last stream, that is what's going to be required for notifications. So eventually we want to create a function that says like ethtool client listen and provides like a channel of notifications. So that's a thing we're going to need. So I guess let's take a look at this. So for short mid-baps, wow, bitmaps of a reasonably fixed length, the NLA bitfield 32 type is used. See, my library doesn't support this, but I'm guessing it's just like a UN32 with some helpers, so that's not that big of a deal. For arbitrary length bitmaps, the ethtool netlink uses a nested attribute with the contents of one of two forms, compact and bit by bit. So compact, I think, is what we're looking at. The bit by bit form, I believe, is what we're doing right now, like the nested attribute stuff. So compact says 2 binary bitmaps representing the bit values and the mask of affected bits. Okay. And bit by bit, which is a list of bits identified by their index or name. Yes, I think this is what we're doing right now. This is the so let's see here. We have like the index and the name stuff, like index name, index name. So I'm pretty sure this is what we're talking about here, actually. Oops. Pub struct, NLA, bitfield 32, value U32, selector U32. Okay, so it's a uint64 effectively, and then it's got some probably methods, or not methods in C, but functions to manipulate it, I assume. So it's just going to be 8 bytes for us, and then we can add accessors, I would assume. So the verbose bit sets allow sending symbolic names for bits together with their values, which saves a round trip when it's passed in a request, or at least a second request when it's in the reply. So this is useful for one-shot applications like the traditional ethtool command. But we're actually probably going to be building a long-running application. So on the other hand, long-running applications like ethtool monitor or network management daemons may prefer fetching the names only once and then using the compact form to save on message size. Not that it really matters that much. Like, saving message size, I guess, will save your user space application from, like, allocations, but it's local communication. It's not like this is over a network or, like, a limited link, so I find that kind of strange. And again here, notifications from the ethtool netlink interface always use the compact form for bit sets, okay? So the bit set can represent either a value and mask pair, which means no mask is not set, or a single bitmap, which means it is set. Value, mask pair, or single bitmap. Okay. In requests modifying a bitmap, the former changes the bit set in mask to values set in value and preserves the rest. The latter clears the bit set in the bitmap and sets the bit set in the bitmap and clears the rest. Okay. So I guess presumably the APIs would. Can you send both, either of these in like a request? Like, can you send the value mask pair or the single bitmap? That seems a little strange, maybe. We're not doing any setting operations now. We're eventually going to add things like setting the link modes and such, but we're not there yet. So the compact form, this is what we're looking at. Hang on, bit set value, mask size, no mask. Yeah, we're using the verbose form still. Okay. No mask, size, value, mask. Okay. So the value mask must have a length of at least bit set size rounded up to a multiple of 32 bits. So 32-bit words in host byte order, words ordered from least significant to most significant. Excuse me, host byte order and then least significant to most significant? Like, doesn't that imply like little endian, or is that just... See, I hate these terms. Like, I wish they would just say like native byte order or like little endian or big endian. I feel like the significant stuff, because it flops around depending on the byte order, is annoying. So the same way as bitmaps are passed with the ioctl interface. So I'm going to assume this all just means host byte order and ignore the significance stuff, because that's everything else in netlink is all host byte order. For the compact form, the size and value are mandatory. The bit set mask attribute is mandatory if no mask is not set. This is what it said before, so no mask is not set, then the bit set mask is not allowed. So this is the structure we're going to have to look at here. The kernel bit set length may differ from the user space length if an older application is used on a newer kernel, or vice versa, right? If the user space bitmap is longer, an error is only issued if the request actually tries to set values of some of the bits not recognized by the kernel. Okay, so for example, if your kernel version is pretty old, this won't necessarily cooperate, but that's the case anyway. Like, if you write an application that uses like a new netlink attribute that's not supported, then it's not going to work anyway. So the nested attribute contents, so it looks like it's more just nested netlink attributes, but in this case, we're going to flag U32, nested, U32, string, flag. Interesting. I kind of failed to see how this is more compact at the moment, because we're still going to have like nested netlink attributes, but presumably the data, maybe there's less levels of nesting, because I think right now we have like 4 levels of nesting, which is a nuisance. The bit size is optional for the bit-by-bit form. That's the one we're using right now. Bits can nest only... Bits nest can only contain the bits bit attribute, but there can be an arbitrary number of them. A bit may be identified by its index or by its name. Listed bits are set to 0 or 1 according to the value. The rest is preserved. Oh god, is this like 1 bit per attribute pair? That seems not... Like, if every attribute represents 1 bit, that seems really excessive. But I guess maybe that's what it is right now for the bit-by-bit form, actually. So, huh. I think probably, let's see here. So request applications can use either form. We're just going to pick one. We're not going to implement both. Form used by the kernel and the reply is determined by the bit set's flag and the request header. Semantics depend on the attribute. Okay. We're gonna try this flag one more time. So where we got last time, I guess before I start writing tests and stuff for all this, I'd like to just get this working. So where we got last time is we can actually parse out these link modes and these specify an index, which I assume is the index in the there's some like C structure that represents like different bits, and then we have like the mode names as well. And this fetches this for all these links, but again, it's this more verbose code. So if we specify the flag that makes this more compact, I suspect my parsing code's going to explode, but that's okay. We want to pass the compact flag as part of this request. I suppose we could either add a flag here. The way this works right now, let's see. Something about like adding a field here that makes certain requests compact. I guess we'll just add it by default and see what happens. So let's see here. U32, Unix, and then this is Unix ethtool a header flags, right? So let's try this, and I suspect that my parsing code is just gonna, yeah, so now we get, we still get the link mode top level fields, but the hours and peer are totally wrong now because we're actually getting a different set of netlink attributes back, as expected. So, probably the place to start is to look back down here and see what sort of things we're getting, right? So instead of getting like the bit value stuff now, bit set, bit value, bit set, bit index, we're going to start seeing these other structures, which are things like the size, bits, nested, no mask, stuff like that. So I would expect roughly to see these. Let's make a new set of functions for now. Advertise links modes compact. And we'll just try this with the hour link modes for the time being. So switch on the AD type. If I am reading this correctly, it could have all three of these at the top. So no mask, size, and bits, right? No mask, size, bits. Trying to figure this out on stream could be a bit of a mistake. I guess we'll see. No mask. We're just gonna dump all the bytes here. That's mostly what I care about. Size, this was a U32, right? So yeah, netlink flag attributes are weird because it just says that like something is present, but it usually has a size of 0. AD UN32. And then the bits, which should be nested attributes. So we'll do that. And for the time being, we're not going to parse anything, actually. So we're just going to iterate these and then do... we are already in a nested context, so we don't actually have to check the error because the caller will do it for us, which is nice. So this will actually stop iterating early if any of the nested attribute decoder stuff doesn't work. Okay. So we're just getting the size. Interesting. Why not the size 75? But there's no flag and no array of bits? Let's see what's in the defaults here. AD type, 80 bytes. Four, 5, 4, 5. Okay, so no mask, size, bits. So it's 4 and 5. Bit value, bit mask. So does this imply that there's nothing? There are no more nested attributes here? Is it really that much more compact? Oh, this is the bit by bit form. Okay, I'm looking at the wrong. Yeah, I should be looking at, this is what I want, actually. I want bit set size, value, mask. So, hang on a sec. Bit set, no mask, bit set size, value. I was looking at the wrong docs. Apologies for flipping back and forth for folks who might be in a dark room or something. Turn on a light. Just kidding. Mask. Right. Okay. So here we are getting size, value, and mask. Okay, so it is just one set of attributes, but now we actually have this more compact form, and these don't look like nested attributes. So actually, this is probably going to save us some work once we just understand how this works. So the value was what, that NLA bitfield 32 type binary bitmap of values. These are short bitmaps. Okay, so I guess if I understand this, these look like short bitmaps, so these are going to be the bitfield 32, but for their arbitrary length ones, it'll be a nested attribute instead. So, I guess for the time being, we're just going to pretend like these are all NLA bitfield 32s. So, thankfully, Terran posted the definition over there, so we'll do, for the time being, bitfield 32 struct. And that'll be a value and a selector, both uint32s. And then we can just go ahead and interpret the value and the mask both as bitmaps, right? Let's see. So presumably once we get this like hammered out and stuff, we'll add these to the upstream netlink library. But for the time being, we're just gonna cheat a little bit. So func parse bitfield 32. This is going to be a netlink attribute decoder. Or no, this is going to be an AD do, right? So I can actually, I'll show you. The do function, yeah, function that takes an array of bytes and returns an error. Easy. So if len b not equals 8, return errors new. Bitfield 32 must contain exactly 8 bytes. Yep. And then we parse the value equals the NLenc uint32 of b from 0 through 4, and then the selector equals NLenc uint32 b 4 through 8. That's that. So now what we get instead is this AD do parse bitfield 32 address var bf bitfield 32. Print line again, value, and then the mask as well. So okay. Type array byte has yeah, bf bitfield. Okay. Size 75 bitfield 32 must contain exactly 8 bytes. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 12. Oh, I didn't even count. That doesn't seem right. Is it? It's not nested attributes. It's... Doesn't make sense. And LA bitfield 32. Hang on a sec. Those don't look like nested attributes to me. The nested attributes are pretty recognizable. Bitmap of valid bits. Are we gonna need to do some kernel splunking? Probably. Probably. LA bitfield 32. So Terran posted that definition there. Let's see here. Hey, what's up, GitHub? Okay. Padding? No, there shouldn't be any padding here because it's already 8 bytes, so it actually would be on x64, or should be sufficient. We could like try parsing these as nested attributes, but I don't see that. So for example, if I just try that, I don't see that working actually, but nested I mean, I've been wrong before. Dump nested. Oops. Good old type completion there. Oh, it worked. Okay. I didn't think those were nested attributes. Okay. Let's see. Maybe this bitmap is already the nested one. So for nested next, log print line type bytes. Okay. Yeah, invalid attribute. Yes, that doesn't seem. Hang on. What does this even do? Well, it creates a decoder, so it created the decoder successfully and determined how many attributes were available, but there's nothing in there? What am I missing here? So this is the compact form, just these 4 fields, binary, bitmap of values. Bitmap of bit values, bitmap of valid bits. This is the more verbose form that we were just looking at. Sets. How about the compact flag? Let's see if the documentation refers to it specifically. Compact bit sets. Does not. Well, we were looking at link modes, right? So maybe link modes mention this. There is a section in here. Hang on. Let's see. Link info get. Or no, we're looking at link modes get. This allows dump requests. Yeah, this allows the compact representation as well. There's a header, but that's not... Am I not parsing the header? Hang on. No, we already are. Never mind. That's part of something else. So we have these nested attributes. 80 bytes. Just see what's in here. Yeah, so this is what you like. This is typically what I expect from nested attributes. You get the length, the type, and then the value is this big blob right here. So like typically you would expect like a length that's like not longer than like 255 normally. So you'll see like blank 0, type will probably be pretty much low too. Like these 4 bytes kind of give it away based on my experience. So this is nested attributes, and clearly we're parsing them in the compact form here. I just don't understand yet. I don't understand yet why. Let's see. This bitfield 32 type that is supposedly that struct over there that Terran has posted. Let's see here. Yeah, let's go over to good old Elixir again. Bitfield 32. NLA binary, NLA bitfield 32. Let's take a look at these. Bitfield 32, valid, macro bullshit. Gotta love it, right? If the attribute len does not equal the size of a struct NLA bitfield 32. Yeah, that's what I'm looking at, right? Value selector. Value selector, yeah. Hey, how's it going? All right. So somebody, I think that I think Jordan called you CryptoSci, and I've always referred to it as like Cryptopsy. Which one is it? We need to know. How's it going though? Good to see you. Probably CryptoSci, because that way it reads out as yeah. Anyway, I thought that was pretty funny. Validate NL of it 30. Cryptopsy, CryptoSci, Cryptopsy. Okay, nice. Cool. It's a death metal band from Canada. Ah, right on. Very cool. Yeah, why? Oh, is that the net? Like autopsy but cryptic. Nice. That's pretty cool. So looking at the bytes for this thing again. Yeah, I don't think this is nested, but maybe there's like a there a header on this? Failed to get link info, but field 32 must contain exactly. Yeah. Let's see here. AD bytes. I need an adult who understands kernel splunking. Yeah, see, if this were like some kind of like header right here, and then this is your bytes, that doesn't make sense to me. I think I'm missing something. Because if I dump the binary of the first couple of bytes, for example, log, hang on a sec, buff 80 bytes. I'm guessing this is going to correspond to those bytes we fetched previously for the link mode. So printf %b buff 0 buff 1 like that. Yeah, so I'm almost positive this is going to line up with what we had before. So we had like what, like bits on one of my links, I had index 2, 3, 4, 5. Oh, no, never mind. I was thinking of... Yeah, so here's one. 10, 12, 13. Like, this link only has bits 10, 12, and 13 set, so I'm guessing that... Here, let's ignore this really quick. And this too. Oops. So 10, 12, 13 on the one. Okay, so 0, 8, 0, 8. Yeah, so here we go. So see, 8 bits, 9, 10, or no, 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, blank, 13. So 10, 11, 13, right? So that would be my 10 gig NIC if I'm guessing, if I'm interpreting this correctly. What did I just say the bits were for that beforehand? 10, 12, 13, right? Oh, but this is 10, 11, or am I reading this backwards? Is this the significant thing? Am I reading it backwards? Either way, this looks like it's probably correct. So I'm just trying to figure out what the extra 4 bytes are, and I haven't figured out yet. Everywhere I see this used in the kernel, I see this rounded up. What does rounded up mean in this context? I'm just trying to understand. I guess we could also take a look at the ethtool netlink. Hang on a sec. So ethtool GENL name. Shit. We just need to get the header. Link modes. There we go. NLA bit field. Oh, NLA. Let's see here. I want the compact code. Right, here we go. So let me make that a lot bigger for all of you. ETH-NL put bit set. How is this defined in 2 places as a function? Oh. Endianness. Oh, yuck. So compact put bit set 32. Okay. Let's go. 232. Okay. Div round up. And this is the non-compact format. So this is what we're looking at right here. Yeah, I'm not sure what the extra 4 bytes are for yet. And of course, this is all kind of just cryptic to me. These names don't mean anything. These functions don't mean anything. Round up the number of bytes to 32. Okay. Like, that makes sense. Okay, Terran's got a link. Bit set get bit. Bit set. Struct NL adder pointer to the bit set. Parse nested. That might be the verbose form. Bit set, mask value. Now this looks like the one we're looking at because the verbose is this stuff down here, I think. This seems, yeah, this seems like the smaller form. I'm just not sure yet. Like, can we just? I don't understand. Like, you know, the last 4 bytes. Like, it seems like we're ignoring data that we might need or is there for some reason. So, I don't know why this is passing 12 bytes because also something else netlink does is it will round things up to 4 byte increments. But the problem is if it's just 8 bytes already, it shouldn't. Wait, is that it? Is that why? Has it got 4 bytes of padding? I guess it's possible. It's possible there are 4 bytes of padding at the end. Because is it rounding it to because the netlink header, oh man. The attribute header would be 4 bytes, so it's possible, I guess, there are 4 bytes of padding at the end. I mean, this seems wrong, but I guess we could just ignore the last 4 bytes as padding, right? I mean, or at least we can roll with that theory for now. I forgot about the struct padding. Anyway, that doesn't sound right to you. Well, we got a couple of uint32 pairs here, and the last 4 bytes is all zeros, so I'm not sure. I'm just not sure yet. But I kind of want to keep moving on this theory so we don't get like bogged down in this. Like, I don't know. Hey, good evening. How's it going? What a weird thing. I mean, the reason I started with the more verbose representation was just because it was easy to do, and it's like, I don't know. I guess in theory we could fetch both and like associate them. Like we could get like the string modes and stuff because that could be useful, but we could also just hard code those in the application like once we get this figured out. So for example, like now we do this and we can test every bit and then determine. So we got the value fields populated and then selector is 0. But with the values, we should be able to test each bit and verify the modes supported as well. It's going to be kind of silly, but also I'm super terrible at like bit manipulations. This is going to be really funny for you all to watch. Unfortunately, this code has no comments, so no idea what they're trying to do. Yeah, that is my gripe with much code. It's like, yeah, this could be, you know, extraordinarily clever stuff, but it's like, I don't know. I think something, you know, I think something like this deserves a comment, right? Yeah. I'm picky. Let's see here. So not bad at all. What about you? Yeah, I'm doing well. Just hanging out. I feel like I was feeling motivated tonight, so let's do some streaming, you know? I had a question. You saw the repo on GitHub and was wondering if there's an idiomatic Go reason to have a client, which represents, don't know what that means. Instead of making client an interface, or just a matter of personal preference. So if we make, the thing is like your packages that are providing types, a pointer to an implementation Yeah, I mean that's effectively what it is, but the reason that exists is because like the implementation technically is different on different operating systems. So I could have like the top level client type like duplicated in different files, but then I have to duplicate all the docs and stuff too. So the way this works is it allows me to hide all of the implementation behind this facade, and then I can have just basically stubs for other platforms and stuff. And the reason it's not an interface is because packages that provide types should not provide interfaces in general. It's up to clients to provide interfaces. So if somebody's using my library and they want to be able to swap it out or do something with tests, then they can write their own interface that swaps out just the methods they need. But in general, you should not provide interfaces in your packages, unless it's like a fundamental package, like an IO reader type thing. So that's my reasoning here, is to deduplicate the documents, the doc comments, and also because my library should not provide an interface, the caller should make an interface as they need to. So hope that helps. So now that we got this bitfield 32, we can actually look at the different modes. What was that? Oh man, what was that type called, Terran? The bit. I don't remember where the stuff was. It's very interesting to hear. Can you point me to a post or anything about this? I'm not sure. I feel like that's just a rule I picked up over time as far as like the interfaces thing. I don't know if there's anything concrete. It's possible. It's possible. I learned it from one of like the blogs or something listed here, but I don't know for sure. So these come from the, there was some constant in the kernel with like all the 10 base stuff, and I don't remember what it was called anymore. 10 base. Thanks a lot. Yeah, no problem. Happy to help. Yeah, so I want like the link mode stuff. There's like a set of strings I'm looking for. And I guess probably what I'm going to do is I'm going to copy those into my library because they're never going to change. And that way we don't actually have to fetch them from the kernel because we're doing the compact representation instead. But I do not remember for the life of me what the type was called. Terran posted it last stream. I guess I could just look for the string in the kernel, right? Like I could just, hang on. Yeah. So if I look for this string literal in the kernel, I'll find it, I think. Oh, this only searches identifiers. Can this search for... Oh, C? C++? You don't know that was days ago? Yeah, no problem. I can clone the kernel locally. Yeah, it's an enum, but yeah, I don't remember what it was called, though, is the problem. So I suppose I could... That's not what I wanted. Let's see here. Let's go clone a kernel, huh? Kernel.org. Is this a tarball? Yeah, it's fine. Oops. It's incredible how many times I get that wrong because I never use these shortcuts outside of streaming. Oh, that was pretty quick. Nice. Go ahead and wait for that to untar, and then CD in there, and I'm looking for like this string. Comes from an enum somewhere. Documentation. It's not quite what I was hoping for. Let's see here. Now we're getting all the Ethernet drivers that support 10G. Oops. Maybe I did want a quote at the beginning. Nope. A quote at the end. Nope. Yeah. God, I can't remember what it was called either. ethtool link mode stuff. Oh. Link mode blank bit. Really? These are a thing? So maybe I can copy the... Actually, do we already have these in the ethtool header? Let's go back to Elixir really quick. These are part of the GE netlink. Oh, they're part of the ethtool header. Ah, yeah, here we go. Yep, this is what I was looking for. So, yeah, I guess we want these link mode bit indices. We want these constants available to us. That would be useful. So, did we already include ethtool.h in the... It's possible it was that blog. I don't remember exactly, but yeah, Yana makes some very insightful blogs, so I would probably whatever advice is in there is probably good advice. I can tell you that. Xsys. So the one thing I have seen that I can tell you really don't want to do is people will create like their client or whatever and then have an interface with like 50 methods, and then that interface becomes totally useless because like you have to implement all of those methods to mock it, and it's not good, you know. We are importing ethtool netlink.h. Now we want to import ethtool.h as well, I believe. Yeah, ethtool netlink.h and then ethtool.h for the rest. All right, it's going to be a bit of a thing. We're going to do it though, because we want the enum stuff. ethtool.h, right? And then we want to... Oh, goodness. What did we just do with this? We went to the kernel source and we include the Perl thing, UAPI, Linux, ethtool.h, and then we're going to use that Perl one-liner that Flo posted at one point, which lives in the Unix repo. Hang on one sec. What do I have open down here? Okay, I can close that. Don't save. Okay, we're good. I want that Perl one-liner. That's what I want. ethtool A stuff. Here we go. Okay. And then Perl ethtool underscore, no underscore. There we go. All right. So we want that dumped to a temporary file in this project, github.com mdlayer ethtool temp text. Okay. I guess I could have dumped it into Unix, but that's okay. Yep. So these will all be things that are useful for us to have, all these bit lists and stuff. So why not? Let's see here. So ethtool and its netlink interface. Oops, shoot. Okay. So with that, I believe we have to run the code generator now. Go build. Go. Oh, not even close. This thing. Good old make all.sh once again. Ooh. I'm a little sore. I lifted weights for the first time in a while yesterday. It feels good though. It's kind of the best actually. Like when you feel like you well, especially when you're back to working out for the first time in a while, you get really that sore feeling, but it's a good sore, you know. I just need to stretch. Back at it tomorrow. I'm excited. Got to start low. I'm only doing 15-pound free weights right now. I know I feel like a noob. It's okay. Pretty much as long as I can do stuff without feeling like my stomach pulling, I'm probably fine. There was one time where I oh man, this was around Christmas, so like only a couple weeks after my surgery, I had a suitcase and I kind of heaved it into my car and I felt like my stomach pull and it's like, oh no. Don't mess with me, surgery. Yeah, this is all going to be useful for us probably, hopefully. Link mode bits. Yeah. Cool. So this will generate some code we can use, and then from there we can do some things where we don't need this anymore. We can actually list out the different modes and such. I still don't understand where the extra 4 bytes are coming from. Like that doesn't seem reasonable to me. It could be padding, I guess. I mean, I want to look at the actual netlink attribute. So we could. Hmm. I'm trying to think here. Because it could just be padding, but I don't know for sure. Hmm. I guess for the time being we can roll with this. It seems kind of silly, but let's take a look at that blog really quick. Now you got me curious, and we gotta wait anyway. So interface pollution, 2014. Oh wow. Let's see. Don't export any interfaces unless you have to. Okay. Interface pollution is not so. You're likely to come from to go that generates a static dispatch table. I wonder how much this still applies. The compiler's probably gotten a lot smarter. Yeah, this is a key point. So if a user requires some level of inversion of control, an on-the-fly interface definition in their own scope would just work. That's exactly it. Yep, minimizes the presumptions you have to make about the way your package is being consumed and the additional abstractions you have to work on. Yeah, so this is exactly it. Like, see, if you want to mock out one method of some client, you create your acknowledger interface, use that in your own code, and you're good to go. So this really is the way and go. Like, if you run into a package that has a very large interface defined, run away. I hang on, I'm curious. I'm curious. Does this have an interface defined? This code is pretty good, and I mean, I've used Go GitHub a lot, but I think it might have some pretty big interfaces in here. Action service, which is some unexported type. That's it's a thing. Yeah, I mean, clearly trying to mock this would be almost impossible. It's got so many methods. Yeah, doesn't matter. Anyway, yeah, define interfaces in your calling code. Don't define them upstream because chances are pretty good that unless you're making some fundamental type or like, in a library, don't define interfaces. In your own applications, it's more so okay. But in like my libraries, I never define like a client interface. Like that's up to people who import my library. So I would like to start using those bits now, please. Let's see here. So we're going to need to parse all the bitfield 32s, and then once we parse the bitfield 32s, create a list of link modes with them. So the mask is... I don't even remember where we were at with the mask stuff. That makes sense. Yeah, good to hear. So the mask is all zeros. Oh, no, the mask is... It is set for a couple of these. Okay. Let's see here. So var values mask bitfield 32. Values and mask. And what we can do now is begin using such things. So, there we go. Begin using these. So the first step would be to, if error, AD error, check that before we actually use the values because we need to verify there was no errors. And then now we apply the values value gets anded with the and equals with the values mask, right? With the mask value. And then now we have the values %0 32b 32-bit integer. I'm not sure what the selector stuff does for us right here. That is unclear to me. Oh, what the? Why is it pulling in Kubernetes structured merge diff? Oh God, no. Where did it value? Oh, I see. values. No, I don't want Kubernetes stuff anywhere near my code. Kubernetes is great, don't get me wrong. It's just it's a lot, right? Okay, so we've interpreted these as the native endianness now. So, oh shit. So 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, blank, 12, 13. So for the 10 gig NIC, we have 10, blank, 12, 13. So those values we will have in the headers coming up here pretty soon are also in 10, 12, 13. They're in ethtool.h. 10, 12, 13. Yeah, exactly. So we have fiber, 10,000 base T, and then POTS. Those are exactly the features I would expect. So that's good. Okay. Let's see here. 10, 12, 13. The problem is now we got to write a big nasty thing that manipulates or sets each bit, checks each bit, and then lines it up with like the name and such. That's gonna be a bit of a thing. To be fair, that code doesn't pull in Kubernetes. Oh, I wasn't sure what it was. I'd never seen that library before, I don't think. But structured merge diff v3 value. Yeah, I have no idea what that is or why it's in my Go mod cache stuff. Anyway. So now probably the thing to do here is to iterate each bit or iterate like each of these link types and stuff and then test each bit. Like this is going to be kind of silly, I guess, but let's see here. So modes, colon equals an array of anonymous structs, where we have the bit int and then the string. And for example, we will have something like bit equals Unix 10,000 base T stuff whenever that's ready to go. And the string will be 10,000 base T full. Right? 12. So we could just hard code it as 12 for now. 10,000 base T slash full. Right? Let's see here. And I'll definitely put these out in like a struct level or a package level constant somewhere or whatever. And I guess we have to test for each mode, right? So if values value and m not equals 0, then we append a new mode. Append a mode of, what do you call it? Advertise link mode. Index is the mask mode bit. The mode bit, and then the name is the mode string, right? So, yeah, 32. That's fine. I believe that'll work, right? Yeah, 10,000 base T full. Nice. Exactly. So, okay, we're getting somewhere. Needless to say, typing all these in is going to be a bit of a pain. I wonder if we could automate that. Or I guess we'll just start with some of the common ones. Like, I don't have any 400,000 base DR4. I wish I had some of these nicks. I'm sure there's a faster way to do this, by the way. I am bit manipulation code is not my forte. It's really not. Link modes map. Oh, I guess I could make this a map, couldn't I? But then we have to iterate. But then if we make it a map, then we have to deal with map iteration stuff. Link modes is an array of structs. Link modes. Okay, that's just done. Let's gotta be close. So we got 10,000 base T. We're gonna have stuff like the fiber and the pause, stuff like that too. So this is gonna be ethtool stuff. I'm gonna need to submit this upstream as well. Oh man, this is more work than I was. Yeah, so we've been streaming for an hour, and I feel like we've barely done anything. But I guess that's how it goes, right? You're never as productive on stream as you would like. Like, I thought I should be... Huh. I figured I would be further ahead than I am, but such is life. Hang on one sec. Let's see here. Sorry, one sec. What's going on, Twitter? Oh, wow. Okay. Hey, we're finally done. Nice. So we should have a whole bunch of constants. Yes, we do. Excellent. ethtool. MDL ethtool once again. Branch already exists. Ah, that's right. Let's see here. Git code review change. MDL ethtool. I forgot about this. Hey, what's up, JV Frat? How's it going? Add ethtool constants for Linux. Let's see here. So the ethtool generic netlink interface also uses these constants. So add these constants in addition to the ones I previously added, and then I'll leave the same comment about for more information so you see. Get rid of the old trailing white space. Gotta love it, gotta hate it. Okay. Git code review mail dash trush dash tribot. I think that'll work. The trust thing is still a fairly new thing. I don't frankly understand really how it works, but since I have +2, I think I can trust my own stuff, and then somebody else with +2 can. Oh, but I can't assign reviewers through here. Ah. Oops. And then another emails, so I guess I will do that really quick. I don't want to assign to Garrett again. So I'll go ahead and do that over in a different browser window. Let's see here. Ian, Brad, Tobias. Done. Okay. Getting there. Okay. Yeah, so we're going to need all these. We're going to need all this stuff. So I guess in the meantime, we can do a local go mod replace again. Just make things easy for ourselves. Oh, gosh. Please no. Replace golang.org xsys unix with, or xsys is where the module is. Oh, man, source. Okay. And I'm going to go ahead and close that and give go please a better chance of catching up with the go mod directives and stuff. Okay. No, I don't want xsys unix anymore. We're done with this for now. I think we're also done with the kernel source for now, but I guess we'll see about that one. Anyway. So there's going to be a whole bunch of modes. Unix.ethtool, 10,000, link mode, 10,000 base, CR2 full. Yikes. How about that? ethtool link mode, 10,000 base T. The text is too... The text is too big. I can't see the rest of the auto completion. Oh, what a nuisance. This is what I want. Pretty ridiculous, huh? Unix. There we go. Okay. Sweet. This is one of those cases where I wish Go had like tuples. Like I don't really care about like the bit and the string stuff here. I just wish I had like a tuple I could use instead. But it's fine. Rust has tuples. Rust they're pretty nice. Anyway, doesn't matter. Oh goodness. Well, I guess probably the easy thing to do here is to go over to the definition and then pull this into a different pane and then go full screen for a little bit and just see what we care about. So probably some of the more basic modes. I think we're going to ignore some of the exotic ones for now. Like this should be a pretty good starting point. You get the 10 base, 100 base, 1000 base, auto negotiation. This is all like the kind of the classic stuff, the non-exotic types. So I guess I will just bring these in. Damn. Hoping to delete all this trailing text. I don't actually know how. I can do multi-cursor up till here, though. Shoot, come on. I think my trackball sometimes gets a little, the mouse click seems not very good, which is a nuisance. There we go. Okay. So we're gonna just add a whole bunch of these really quick. Uh, 10 base T, half. Stuff like that. Don't get me wrong. I'm sure there's a faster way to do this. I just, I don't know it. So we're gonna deal. We will survive. You'll watch me do pointless toil on stream and you will like it. Pretty silly, huh? 100 base T, half. It's kind of weird. I've actually never used any like half duplex modes. I wonder if that's just like older gear. You know? Ah, shit. 100 base T, full. Half full, half full. I guess I could just make this easier on myself and just add a couple zeros here, right? So 1000 base T, 1000 base T. Good old 1 gigabit. Okay, now we got auto negotiation. I'll go ahead and give myself a bit more space here. I wonder why auto neg. I mean, I feel like you could almost just like spell it out. Shoot. Maybe for some of these I should spell them out like I do in the package, like the TP. I feel like TP is a weird thing. Let's shoot. Twisted pair. Let's do it. Why not? Probably come to regret this later, not lining up with what the kernel says, but AUI, and then there's MII, which I could just copy and paste a couple of letters here. Isn't half duplex for hubs? I don't know. I've actually never owned an Ethernet hub. We have the fiber bit. Then we have BNC. Then we have 10,000. Then we have pause. So I'm sure we can automate this. We could build a thing that could like write out the code for this. I just haven't at the moment, you know. So anyway, that should give us all the link modes for the stuff I care about. So let's see here. So to do MD layer, build something to automatically populate this list. Link modes is a list of Ethernet link modes attached and their associated ethtool bit and string. Okay. So now, what is this size thing for? Bit set size. Wait, oh, hang on. You know, we were talking about with the padding and stuff. Maybe bit set size, right? Didn't it say 75 earlier? That seems larger than 32, right? So, oh, what's up, Dot Waffle? Also for 10 base 2, which is where you had one long coax cable everyone hooked into. Oh, like the vampire tabs, right? It was really cheap to build, no extra electronic hardware needed. Gotcha. It had collisions, etc. that you don't tend to get. Gotcha. Yeah, that was all before my time. The number of significant bits. Okay, so there are 75 significant bits in this. Interesting. That was 10 base 5. Let's run this again one more time, but I think this is pretty close to just working at this point. Raja Silan, thank you for the follow. Welcome to the stream. ethtool. NL ethtool, right? Yeah. Oh, shoot. I did it again. Submitted code without checking to see if it builds. Yep. Man. Previous declaration of ethtool VX off, redeclared. Yeah. Damn. Yep. Good old bad habit. Xsys Unix. Grep-R for this. Where does this exist? Twice. Types.go and then make errors. So we're going to need to remove it from the types list. VF off. VF off. So apparently this was imported somewhere else. All right, let's build the damn thing before we submit it this time. RX flow spec, right? Do I have this? Yeah, I do. Okay, one sec. Flow. Oh, I have to run the code generator, don't I? Ugh. Well, I could cheat. I could modify the file manually because we know that we're removing one line from it. And save myself the effort of running the code generator again. We're gonna do that. Don't tell anybody. It's fine, really. It's fine. Do not edit this file. It's fine. Yeah, that looks like a pretty reasonable diff to me, you know, compared to running the code generator and waiting. So, change. And mail. Uh, 10 base 2 was a network my friends and I used to create for 4 hours every Monday at the local computer club. That was 1997 or so. Crikey, I feel, wow, nice. That's pretty cool. What is the bottleneck on the code generator? Maybe that's worth spending a little time speeding up. It does some QEMU magic with like different architectures and stuff, and I don't know it well enough to like speed it up at the moment. Potentially some of that work could be parallelized. I'm not exactly sure, but it's okay for now. We'll survive. We can close a bunch of tabs at the moment. Coder Talks, welcome. Thank you for the Twitch Prime sub. I appreciate that. Welcome. Enjoy your emotes. Hey, check it. We got link modes. 10, 100, 100, 1,000, 1,000, auto negotiation, twisted pair, AUI, MMI, fiber, BNC. Let's go. Wait. That link has like every mode. Doesn't seem right. Yeah, my logic is wrong here. Sub hype. Yeah, exactly. That's not quite right. There's something wrong, I think, with my bit math there or something. Coder Tux, thank you for the follow. Wow, I got the Twitch Prime sub before the follow. I appreciate that. Thank you. So we mask it off. We check if that and the bit is not equal to 0. That checks if the bit is set, right? You've been watching for about 2 minutes and you're hooked. Oh, nice. Very cool. Well, I'm glad. I do what I can, you know. I suspect that this is not giving me the value I want here, right? I think this is me doing something really silly with bit math. Yep, okay, well, it is set for... Huh. So what's the original... Just the first NIC now is getting... So my 1 gig NIC is getting all the modes for some reason, and my 10 gig NIC is no longer getting any of them. There's something obviously wrong here with my bit math, I'm sure. So we're checking using the mask with that bit to determine... Oh god, this isn't like an endianness thing, is it? Oh, yeah, I think you're right. Yeah, that's silly of me. Wow. Yep, I forgot a shift. Yeah, that's about right. And let's see here. So, yeah, it's gonna be 1 shifted M bit times, yeah, to test that bit, not equal 0. I bet that'll do it. Yeah, fiber 10,000. There we go. Yep, good call. I appreciate that. It's like, oh, if you and it with the value itself versus the bit, yeah, that's a thing. Oh, thanks. Only apply. Wait, are those trucks being printed like that? Yeah. What is that, Voodoo Magic? This is the Go Spew thing. So this is a nice little. Let's see here. I've been using this for ages. There are new things, but I like this because it shows you the things like the capacity of slices and such too. So I think it's kind of abandoned-ish, but for local debugging, it's very, very useful. It shows you memory addresses. It shows you the capacity of things, etc. It's nice. Yeah, it is a lot better than format sprintf, for sure. I'd like to say you worked it out, but I'm 99% sure I've done that mistake myself in the past. Yeah. Just like when I'm on stream, it's like you don't always notice little easy things, you know? Like I'm just kind of like working and I'm like, oh, whatever. Only apply the values according to what the mask. Only apply modes which exist after the mask is checked. As applied. Bits in the values bitmap will match link mode bits as defined. Link mode bits from link modes. There we go. Cool. Yeah, this is I'd say this is actually a lot better than the non-compact version. It took us a little bit of tinkering, I guess, and we still need to add a lot more modes, but this does seem nice for sure. Probably what I could do instead is I could just actually iterate over each bit and just apply add a mode with like an anonymous name if I don't have it, but for the time being, this will work. So we can actually get rid of these 2 functions, which is great. And then we just do parse link modes compact as well. And then actually we can just go ahead and rename this to parse advertised. Oops. Here we go. Neat. Yeah, no pure link modes being advertised. I don't know if you need like fancier nicks for that. Maybe that's true. Yeah, I want to get back to this size thing. So it says size 75 for all of this. That imply there's 75 bits in that bitmap, right? Oh shoot, I closed Elixir. I want stuff like the ethtool constant again. I want to look and see how many bits there are defined. There might be 75 modes. That would make sense. So let's see. I'm going to copy these to the very bottom of the file so they're out of the way. Why did I just close? Yeah, I didn't want that. I wanted to go down here. So we're going to look up this again. Take a look at that good old enum. And we are going to, there we go. 31, yeah. So, oh, there are more than 75. Of course, this is on tip, and I'm running my machine, so my machine probably isn't aware of these. 91, 100 base FX. Were these added that recently? I guess it's possible. I don't know anything about these other nicks. Like mod mask and bits. Because if I were to run this on my server, which is a newer kernel, it's actually running kernel 5.10. Let's find out. Let's do that. NL ethtool on the old server. Oh, right. NixOS got a no cgo. Cgo enabled 0, go build. Okay. Size 92. Yeah, see, so it's newer kernel. Okay, so yeah, that actually tells us the number of bits defined. Okay, that's sweet. Cool. So we can actually provably verify that the number of bits is dependent on your kernel version, and in the newest kernels there actually are 92 entries, which is neat. Hey dude, good luck, have fun. Yeah, will do. What's the 1,000-foot view of what you're working on here? So, basically, there is a tool in Linux called ethtool. Do I actually have it installed on this machine? Yeah, I do. Ethtool, EMP4SO, right? 5. There we go. So there's this tool called ethtool in Linux that actually tells you a bunch of information about like the low-level like device driver and physical characteristics of your network interfaces. And this has had a kernel interface for a long time, but it was kind of an old interface that was difficult to work with, especially in languages like Go. But they actually added a nice netlink interface, so we're actually building a new interface for this from Go using the new netlink interface. So we're getting access to all this information, but using the new netlink interface, which should be pretty sweet. So yeah, so far so good. Having a good time. Awesome. Yeah. Yeah, for sure. It's pretty cool. Go looks fantastic. Yeah, I really like it. It's people have opinions about Go, you know, but I think that it's an extremely productive language, and I think it's worth using. So, you know. I wonder where the no mask stuff applies. It doesn't seem like there's no mask here. It seems like there always is a mask. Anyway, so the kernel will tell us here like how many bits are considered significant. So we could potentially do a shift. Could we? No. We could mask off bits above the certain... Huh. I'm debating if we need to do any sanity checks with this size thing, right? So if I run this tool locally here, on my machine currently it says 75, but on my server it says 92. So my machine recognizes 75 different Ethernet modes, and I'm curious if... Let's see here. So in a uint32, you've got, yeah, 32 bits. Does that imply... If I run this on my server, hang on. 92. I want to take a look at the bytes again for the values in the mask. F, %B, %B, values, value, mask value. 032, 032. These are both uint32s, right? So now we need to cross-compile, or not cross-compile, cgo, no cgo compile. Come back down here, run this again. Looks like the masks match up exactly, but what I find interesting here is if there really are like 90-some bits, then what happens if this is too big, right? Because we only have space for 32. It seems like if I had a different NIC, would it have the different representation? Like if I had a fancy NIC, would this give me a different representation? I don't know. And then frankly, I'm still not sure what the selector field is for either, you know? Value selector, mask selector. Actually, isn't the selector stuff documented in the NLA bitfield stuff? I think it might be. We should go take another look at that. But selectors are always 0. Yeah, I should One sec. There we go. So I dropped a link in the chat, like recommended Go resources again. If Go is something you are interested in learning, these are all good resources, I think. So enjoy. Hmm. You assume the selector does something like bank switching does in memory. You select which bank bits retrieve. Yeah. So this comment right here. So last allowed bit is legacy mask bit is 31. Please do not define a supported or advertised macro for bits greater than 31. Only way is to use the new ethtool link settings. Link settings. Interesting. So that's an API. ethtool G link settings. Oh, these are like the equivalents. Hang on. Yeah, request translation. Yeah. Is this telling me I have to ioctl to get the rest of the link modes? Because I'd rather not. We're gonna do a thing. This is kernel 4 something. I assume it's okay. G link settings. Well, that seems curious. Yeah, I agree. G link settings. Yeah, it's not something I would expect them to port into a new API. I would expect them just to do the new bitmap format or something like the arbitrary length bitmaps. But yeah, I guess it's possible here that the selector. Yeah, I guess it's possible that the selector would select a bank of bits. So, for example, like 0 through 32 are in the first bank, and then like 32 through 64 are in the second bank with the selector, right? I think that would make sense. The problem is I don't have any hardware that I can actually test this with. Maybe I could run this at work. Maybe we've got some fancy nicks with some of the newer modes. I bet we do. So I have to go borrow a cache node tomorrow. I'll figure it out. I will follow the rules. But that's a thing. Can you paste the URL of the bit mappings? Yeah, let me see here. Right here. Listen. 1521. Oh, just to see if you have access to something with a high setting. Yeah, totally. Yeah, that's a thing. FEC DR2. I don't even know what a lot of these acronyms mean, honestly. 100 base FX. Yeah, I think we're probably gonna roll with this for now, but let's see here. So to do MD layer, consider capping the number of valid bits or similar based on what the kernel tells us here. Do a quick check for errors before making use of the bit field 32s. Yeah, so we're actually doing this now. So a bit field 32. So this is something that, yeah, if we keep encountering this, we could potentially put this in the netlink library. So bitfield 32 is a NLA bitfield 32 structure to do MD layer. Consider moving this with convenience methods to package netlink. Yep. Parse bitfield 32 parses a bitfield 32 structure from raw bytes. To do MD layer, what are the last 4 bytes? Netlink padding? It's possible, but it doesn't seems interesting. You know, we should go look at the definition of NLA bitfield 32. Excuse me. Because I'm pretty sure it mentioned what the selector was for. I just didn't quite comprehend it at the moment. Here we go. Which being set, which value is legit. It's a bitmask that defines which value is legit. Okay. Too legit to quit, I guess. Blue Spider Monkey, welcome. Thank you for the follow. Appreciate that. Yes, it does number 31, but you don't. Yeah, it must have something work with this 25G SR 100G port. Yeah, we will. So I'll have to play with this at work, but I guess it would make sense to me if the selector was used to flip through the bit banks or something in this particular case. But yeah, I don't know. I don't quite understand. Actually, hang on. Is this upstream? Is the NLA bitfield 32 thing? NLA bitfield. Nope, it's not. That's okay. Fixed it. Cool. Okay. Moving on. Hey, you're getting into ethical hacking. Do you do a code review at the end to look for vulnerabilities when you build stuff? I wouldn't say that. I would say generally what I do is I tend to think about things in terms of like, defensive programming from the start, right? So for example, like you want, defense in depth, not security by obscurity, etc. Like if a request header can only be one of a couple of values, then enforce that it's one of those or something like that. Like these are all kind of small things you can do to just tighten down your code. Like if you know that something doesn't need to be as flexible as you've made it, then tighten it down. Make an enum, make something a boolean instead of a string or something like that. I would guess that's kind of the way I approach it. I don't specifically audit for vulnerabilities, I guess. But also I don't really have a security background, so I just tend to do my best to write secure software, and things work out usually pretty well. But of course, everybody can make mistakes, though. Parses the compact nested attribute format for a slice of. There we go. Sweet. I guess what we could do here is we could make it so that it looks up we could iterate each bit up until size. So it's like I could iterate. Oh, sorry. I could iterate each bit up until the size value, like go like for I equals 0, 1 through 75, and then just match each bit. And then if there is a mode, add it, or otherwise add like an anonymous mode, like mode bit whatever. I don't know. It's probably okay for now. Probably don't need to bother, but. Oh, what do we got? Oh, stuff with my Garrett tribots passed. I got an email. Cool. Okay. Now, actually, we need to verify that our previous requests work with the compact form as well. If we just pass that flag unconditionally, what happens, right? So... link modes, and dump the link info, please. Thanks. Okay. We are done on the server for now. Go run. Ship it. So it looks like link info works fine with the compact flag. So I guess I'll specify that on every request. It seems fine, But my test will no longer pass, actually, because the tests don't look for it. Yeah. So... unconditionally add the compact bitsets flag, since it will since some of the ethtool notification AP, so since the multicast groups, since the ethtool multicast group Group notifications require the compact format, so we might as well always use it. Ethtool. There we go. Okay, now we got to fix the test and then write the new test. So let's have a link info header. Let's have a link info header with only flags. No requests for an individual interface. Okay. That one passes, I'm sure, now, so now we need to make this one pass too. There we go. Easy enough. Okay, cool. Now we are at the point where we can start writing tests for that, the link mode stuff. Cool. What time is it? 6:30. Not bad. Apollo Simpson, welcome. Thank you for the follow. Appreciate that. One sec. What is going on? Okay. So we need to write a test that deals with this code as well. So empty response, 0 link infos. Yeah, this test doesn't really apply anymore. We don't really care. I think we got rid of the special case for 0, so I think we can just go ahead and wipe this test out, actually, which is fine. It doesn't actually give us any coverage. It's just kind of something else we have to maintain, which is a nuisance. So I would rather not. But now we're going to copy and paste these because we're going to essentially do the same things. Trackball, man. Need to like clean it. I need to like pull off the top again and like swap it out. But it's a bit of a nuisance. Anyway. Infos. Link info. Actually swap a lot of these. This is not quite going to work, but it'll be close enough. Okay, link modes. Let's see here, index name. We need something to encode link modes as well. I thought we link modes get link modes header. I see. Expected link mode, link mode, link mode. Replace all the instances of LIs here with LMs for consistency. See, yeah, we're gonna change that as well. Good old multi-cursor, huh? I should probably use this. It's gonna be easier. LMs. There we go. Link mode and link modes. Okay. I mean, something that can encode link modes. Yeah. This is going to be a bit of a nuisance because I think now we have to encode the compact format as well for this test, possibly. Oh boy. Oh boy, oh boy, oh boy. It's not that hard, I guess, but it's not great either. I guess in theory, eventually we're gonna have to, if we allow things like setting the link mode, right? We're gonna have to encode the compact format. So link mode set. Mm-hmm. This auto selection is done on the ethtool side with the iactl interface. Netlink interface is supposed to allow requesting changes without knowing exactly what the kernel supports. Huh. Yeah, we're gonna have to figure out how to encode this stuff as well. So the duplex and then the speed and well the hours and the peer, that's gonna be the pain part. But we can make it work. It's gonna be a good old time though, that's for sure. But I guess in theory we're gonna write these functions in here for the tests, and then we're gonna be able to reuse them or put them out in the main code, which will be useful. We're just not there quite yet. LM. Actually, we're going to need to specify the compact flag in these requests as well. Because we're going to start passing the compact format for everything. That's a thing. The trouble I get myself into, huh? Link info port. Yeah, it's not even close. So now we're going to be looking at the link modes stuff. So the link modes header contains the index, the device, and then the compact boolean. Actually, so shit, are we seeing that flag now in our code? Unix ethtool. I think we probably are. A header flags. AD uint32. I bet we are seeing this in our own code. So the kernel can confirm to us that it's passing the compact representation. We are not getting that back, interestingly enough. I would expect the kernel to send that, actually. Ethtool A header flags. Yeah. Why wouldn't it, if we ask for the compact format, why wouldn't it tell us that it's giving us that, right? So something else we could do is we could actually, if we want to capture netlink messages and stuff, we could actually use an nlmon interface and like use TCP dump, and that's a thing I've done once or twice. And actually, I'm probably gonna do it at work tomorrow too. I don't know if you saw my tweet, but I having fun today with IPv6, MPLS, multipath, next hop stuff, yada yada. There's probably something very subtly wrong in the library somewhere, and what are you gonna do? But I will fix it. I'll make it work. Yeah, why aren't there... I would expect there to be header flags in here. Or something. I mean... Right? Over here. Odd. So it's just giving us back the type, the index, and then the name. I don't quite understand why, though. I would expect both. So I guess this would seem to imply that we aren't passing this as when we encode the structures. Anyway, I guess for now we'll leave it alone. We need to look at... So we pass a header, and then we also pass our link modes, the peer link mode, and the speed. Let's start with the speed. That's easy. So link modes speed, right? Which is a uint32. Speed megabits, right? Uh, 1,000. Speed megabits, 10,000. Okay. Now, do the tests pass? Close. They do pass. Okay, so we're successfully encoding and decoding, doing the round trip for the link modes. Now we got to do, we got to do the advertised modes, which is all this bit set stuff. So we have to write some logic to deal with that as well. What a good old time. Okay, yeah, let's do it. Let's figure that out, right? So, let's see. The link modes are nested, right? So we just open up another nested encoder. Ethtool a link modes ours. We'll do just our own link modes for the time being. The nested encoder now. I'm sure we can split up more functions here too if we need to, but for the time being, this should be fine. The nested encoder is going to have everything we do in here. So we're looking for potentially the size, which we don't look at right now, the value and the mask, right? So we pass values, so the modes that our NIC would support. So what I could do here, I could do something like this, right? So AE, uint32, no, not uint32, AE bitfield 32. So we actually need 12 bytes here, so AE do Unix. This is gonna be a bit of a thing. Anyway, return nil. We need to return 12 bytes because this is going to be the bitfield 32. So the first 4 bytes are the value, and the second value selector, and then padding. So make 12 bytes, and then we stuff a uint32 into the first 4 using the native endianness. So native endian. Do we have an netlink put uint32? Yeah, we do. 0 through 4. Now, what we need to do actually is specify the individual modes for the NIC. So let's pretend this is a 1 gig NIC. So the modes would be a bit mask of fun things. So, for example, we could do 10 base T. Now, let's say 10 base T half. So 1 shifted by 10 base T half. And then we OR this with other fun things, like 10 base T full. And I think for the time being, that's sufficient just to test this theory, but I think we're going to write code that looks roughly something like this, maybe add a helper. But this is going to be a bit of a doozy. That's life. We will survive. Nested attribute encoder. Almost got that wrong again. So now we have the value, and then the mask. There's going to be no mask at the moment, so it's going to be all completely masked away. So we're going to have to do the same thing for the mask. So we're going to need to make a helper here for the... We're going to make a helper function for the mask as well. We'll pass the same thing. Actually, we could just bitmap. Bitmap colon equals... bitmap. Right? So we have a function that creates 12 bytes, which is the in-memory representation of the NLA bitfield 32. We're populating the first 4 bytes, which is the values, with a couple of flags based on 10 base T and 10 base T half and full modes. And then the code should parse both these, mask it off, and then give us back advertised modes, right? I mean, yeah, here we go. See, we're advertising 2 modes now. We're advertising 10 base T half and 10 base T full. Oh, man, what a thing. What a doozy, huh? The trouble I get myself into, huh? Well, we're 2 hours into the stream, and I feel like we've made no progress. We've actually made a lot, figuring out this compact format and stuff. I hope you all are enjoying this. uh, I don't think today's gonna be a 4-hour stream. I think we'll see where we're at in like another hour. But I'll probably want to chill out tonight because it's a weeknight. Let's see, where are we at? By the way, so Large Databank is off on Friday. He's not gonna be streaming, so I will be probably streaming around his time block instead, stealing a spot. You know, 1 base T, 10,000 base T. Yeah, exactly. Yeah, I think what I need to do now is I need to make it so this isn't hard coded. I need to like make a function here that takes the modes and applies them in a loop. Yeah, so I think I know what I need to do here. I need to tidy this up. Pack bit field 32 is a function which returns an array byte error. Actually, it needs to be needs to take modes. So advertised array of advertised link mode. We'll call them LMs again, or ALMs, because that's what we're calling them before. So this returns a function which takes no parameters. So it's be a closure magic func array byte error. Here we go. You ready for this? Var values uint32, and then for ALMs, we're going to values and equals with ALM dot index 1 shifted by the index. We apply the mask for each one, and then we pack it in. So now, like so. I believe that'll do it. To do MD layer pack selector when needed. What's the resolution of that monitor? It looks like a relatively large. You use a small font. I am actually, yeah, I have 3 4K monitors. So I'll send the link and stuff. But yeah, I'm using 3 4K monitors right now. I'm streaming in 1080p, but also I've got the fonts really blown up so that way everybody can see it on stream. I normally code at like size 14 font. I think this is 22. So it's bigger than I need, but it's much nicer for the viewers that way. Pack bit field 32. LM hours. So the hour modes are the same. And then the peer modes. Do layer set bit set size attributes when necessary. Yeah, my setup was kind of ridiculous. The thing is like I know lots of people can get by with like just a laptop or like a laptop and 1 screen. I've always enjoyed like 3 screens. Like this is like my optimal setup, and I can't even think of what I would do with like a 4th if I were to add one, you know. But my graphics card supports up to 4. But 3 4K is I've got 2 horizontal over here, 1 vertical over here, and that works really well for me. Okay, so now if we advertise some link modes here, but you work from home and use a lot of reference material, so it makes sense to customize it to what works best for you. Yeah, that's exactly it too. Even if your wall is just covered in bottles, yeah. 9840 by 3840. Yeah, not quite. Well, so the geometry is really weird because I have this vertical monitor on the left, so sometimes like the X window geometry stuff gets really messed up. And for example, like my wallpaper is stretched in this monitor, which is a nuisance, but what are you gonna do? Anyway, advertised link modes is an array of advertised link mode, or a slice, excuse me. I always do that. Index. what was it called? Like 1. I guess this is where I can use the Unix constants too. I think I'm just gonna cheat a little bit here and just use a couple of modes instead of having to advertise all of them. Index. Oh, ours. That's what this is called, right? Yeah. Okay. You want that, but you got nothing. Is the parsing failing somewhere? Man, what a mess this is. Link modes, ours. We are packing these appropriately, right? So encode link mode, ours. Pack bit field 32 with our values. Yeah. So we're anding off each bit as we go. Oh, shit, we shouldn't be anding. We should be Ring. We're setting. I'm done. There we go. There we go. It's kind of funny how those little bit operations, like, just you forget the tiniest little things, you know? And then we'll add the names too, because the tests are going to complain for now. 1000 base T, half. And 1000 base T full. There we go. This will be 10,000 base T. And then fiber for funsies. Link mode, fiber, bit. Okay. 10,000 base T full. Did I spell it wrong? Oh, index 1012. Oh, the ordering is wrong. I see. Yep, there we go. So now our coverage is looking pretty good. You mentioned fiber is for fiber channel, not the British spelling of fiber. This is actually an SFP plus, Nick, so I was assuming it was just the British spelling of fiber. I imagine fiber channel isn't Ethernet. Well, so the reason I added this is because my link actually, or my nick actually advertises the fiber attribute, and it's just SFP plus. See, so I would assume that fiber channel actually is not involved in the ethtool APIs at all. It's probably totally different. So I'm just going with this for now. Right, yeah, fiber channel is not Ethernet except when it's fiber channel over Ethernet. Right. Yeah, I know it has like its own like physical layer and everything. Yeah, so I'm just gonna go with it. It's what it is, you know. Yep. Cool. We done good. Let's see here. Put an Easter egg in Marsh or something. This is why you should always listen to me. Yeah. So now we're going to get to the point where we're going to have some duplication in the tests for things like the dev cases and stuff like that. I guess it doesn't hurt to test all those, but I feel like I should test them elsewhere, possibly. I guess what I could do is I could have like an errors test or something. So for example, if I take this really quick, I can simplify it somewhat. test client is not exist, right? Or test client bad requests, something like that. And then I will get rid of the successful cases here. Error no, and check function, no link info. There's a request. So then the function we call, we need to actually call different functions too, right? So all I really care about here is passing. Hang on. No, we don't need really any of this. So we'll just have the error number stuff. Return a canned error number if you get this far. So if any of the calls actually make it to netlink here, we'll return an error in this case. That's what we'd expect, right? And then we will parameterize the client call. There's going to be a function that receives the request of the client. One sec. Sorry about that. Got a friend asking me something. What's up, Twitter? Oh, hey, Bill Kennedy followed me. Nice. I know for a long time, Bill, like, he has his, whatever the area code is for, like, Miami. I think it's, like, his number of Twitter followers, like, he's allowed to have or something. So the fact that Bill finally followed me is an honor. Pretty cool. Gotcha. Yeah, it looks like we got a, hang on a sec, ethtool +2. Hey, sweet. Our constants can be merged in, which is good. I will go ahead and merge those in a different Garrett window because I'm not signed in again. Sorry. Where is my change? So something I'm sure is on all of your minds today. Did you all see the generics proposal stuff? So it is still a draft design, but now there is an official proposal to make it happen as well, which I think is very cool. So I understand that it's going to be a bit of a controversial thing, but frankly, I think it will be. I think it will be pretty welcome. Okay, so this is merged. I just went ahead and merged that. Sweet. I think the generic stuff is overall quite good. I actually did a blog on it a number of months back. I think the syntax actually is different now, so this doesn't compile anymore. But if you are interested, I built a toy hash table using the generic draft design in June. I thought this is pretty fun, you know? And I think the thing is that much like Go routines and channels, when somebody new comes to the language, they're going to reach for all these tools, right? And when you were new to Go, if you've written Go before, you're like, oh, well, Go routines make everything faster, channels, async, all this stuff. And it's like, you kind of end up with a mess, right? And I think we're probably going to run into the same situation with generics. So a bunch of people commenting and rehashing things already discussed. Yeah, that's what I expected. I already went through the thread and hit a few comments from people who were not being productive. So what are you going to do? But yeah, I'm excited to see this go forward. I think that overall, this is by far the best approach that we have seen. So here's hoping, you know? Yeah. So pretty cool. Pretty cool stuff. Let's update our dependencies and get rid of that go mod replace. That'll be a good thing. Pull everything. Did we get new versions of... Get rid of the old... Actually, I think I want to do go proxy equals direct right now. Go proxy equals direct. Cool. So at this point, we should have access to all those constants we need. I'm just going to restart this again for go please. I know there's like a command to restart go please. I just always forget it. Anyway, yeah, should be in good shape now. So I think what I wanted to go, where I was going with this is I wanted to make it so that you pass a function here, and all the functions we can actually verify that they get tested appropriately. So right, so a function that... Wait, I think we can use a go trick here. You ready for this? Oh shit, never mind, it won't work. I thought we were going to be able to use the method expression, like method function expression syntax here, but we can't because they return different types. So such is life. We can make it work anyway. So I want to test it for empty request, enodev, and eopnot support with these things. We end up in a situation where we get an error back from netlink or from the library. So effectively what I want here is we're going to get rid of all the return values. We are going to make a series of calls. Actually, we might even have nested subtests here. Let's see here. Yeah, so we might have subtests for each of these cases as well. So what I will have is something like calls is an array of functions which take a client and a request struct. And we'll iterate over all of these, and I'll give them a name too. Actually, I probably should do that. So a map, but I don't like maps. Another array of anonymous functions. Name string fn func. I'll explain where I'm going with this in a sec. I apologize. It's just let's see here. Link info. Request should return an error. Yeah. So we'll do that actually. We'll make it say return errors as well. Underscore error, C link info, R return error. Yep. Tests, subtests, test subtests. Link info, link modes, link mode. Yep. So we're actually going to iterate through all of these cases as well as these function calls, and we're going to test everything here. So for underscore call range calls. Call name. Okay. Move all of this within the context of the new closure. I kind of love the first class function stuff in Go. This is the first language I've really like gotten it with, and I feel like I can really leverage it to my full advantage, you know? So call with C and the request. And then all of these errors should be non-nil. So call.fn. I don't like the name call anymore, though, so this is fn's. Fn, and then we'll call this call instead. Function name, function call, right? So now we can actually verify with subtests that all of these cases are matched for every one of our client APIs. So we're actually upholding our API contracts no matter what, which is great. I like that. Should pass. Yeah, it does. Excellent. Test client bad requests. These aren't necessarily bad requests. Test client errors, right? So we verify here that whenever we get enodev or eop not supported from any of the operations, they return the error we would expect, which is OS error not exist, Or if you pass an empty request to any of these functions, they give you an error bad request. Right. Pretty good. So now we can actually simplify a couple of the other cases here. We can get rid of the error tests in here. So these go away. These go away. By index, by name, both. No errors. No more. Failed to get link info. No more error checking here. Things simplify pretty nicely, you see. There we go. Yeah, sometimes I'll have like tests for testing like only successful cases or only errors depending on the number of inputs involved. Like this test had like 6 different inputs and that was starting to get kind of nasty. So I'm glad we can simplify it a bit, you know. Feels good. And now I can actually inline this because it's only used in one place in this function. Okay. I expected that people would start arguing about the generics proposal as soon as I mentioned it, but nobody said, or Taryn said something, but nobody else really did. That's surprising. Yeah, we're actually gonna overwrite that with the newer version. Let's see here. Peer link modes, our link modes. Yeah. Okay, I ran out of water. I'll be back in a sec. All right, we're back. And standing desk time. Should have done that earlier. Feels good. Let's see. I was thinking about simplifying this slightly as well. Just because we can remove a bit of duplication here if we do a function. So for example, if I call this like fn well, you figured out your missing Prometheus metrics problem, real derp kind of day. Using a 64-bit int to represent epoch timestamps have the time skew. Huh. I mean, I usually use timestamps for that, but then you have to use a float for Prometheus, I think. JV Pratt, thanks as always. Hey, thanks for stopping by. I appreciate it. Take care. If you're taking off. Pack link modes. Pack advertised link modes. I'll do this instead. Array of advertised link mode. Pack ALM's calling equals. What am I doing? A function that takes advertised link modes and a type. Let's see here. Yeah, Unix, ethtool, link mode, hours, and hours. So we do that. And we call theirs, or appear. Yep. There we go. Nice little simplification there as well. More first-class function shenanigans. Oh my God. Okay. Feel pretty good about this overall for sure. So we have the successful link modes case. Index name speed, megabits, hours, peer. The peers don't advertise any link modes in our case, so I think we'll just leave it empty for now. But I think the code gets called though, right? It does not. ethtool a link modes peer. Because we're not actually packing it? I thought we were. thought we were, yeah. Oh, shit. This is why. Type. Now we are. Okay. We done good. I'm talking to some people locally. We're gonna buy some whiskey. Should be pretty good. I'm excited. There is a SMWSA, the Scotch Malt Whiskey Society. This is a fancy club that has like their own bottles they pick and stuff. And we are going to order. We're going to do a group order of this because I have a membership and we can get these. And if we buy more than one, then I can split shipping with people. So delicious Cull Ela, 56.3%, 12-year cask strength Isla Scotch. Gonna be super good. I'm excited. I'm a little bit obsessed, but you know, pretty normal for me. Oh, let's see here. So a couple of these comments, things like this are going to be duplicated everywhere. Um, I guess I might. I guess I might remove the comments and put these up out of the scope somewhere. So, for example, let's see here. Let's see here. Note that some client methods may panic if the kernel returns 2 an unexpected number of netlink messages when only 1 is expected. This means that a fundamental request invariant is broken and we can't provide anything use to the caller. So a panic seems reasonable. I like justifying my design decisions in my code. You all have probably noticed this, but I tend to comment probably a lot more than most programmers. Hey, how's it going, Live Cratchy? I'm gonna move this down with the other unexported methods. Actually below get, because get is wrapping this. Okay. Got a few nice layers of abstraction here. The library itself is not that complicated, just the tests, really. I mean, I feel like that's the way it should be with this kind of stuff. You know, if you're doing all this bit packing and whatever else, like you want to make sure you get it right. So having tests be more complex seems pretty reasonable to me. You know. And of course, I will document the test code better if I move it out into the production code as well. But I tend to be a little more lax with tests because, like, you don't have to worry about like Godoc and stuff. Wow, what is going on? My phone is exploding, which means something might be happening. Oh, great. Yeah, that's nice documented code. Thank you. Yeah, you know, people have different opinions and stuff, but I'm pretty serious about it. And I try and not push my style too much on coworkers, but you know, sometimes I will a little bit too. But I think that people like to use my code as like an example sometimes, so I try to take it pretty seriously. We got the link modes. Now we need singular link mode call. Like so. Link mode by index, link mode by, yeah. So we're gonna, once again, multi-cursor magic. Okay. Yeah, we're gonna try and keep this a little more simple this time, I think, without all the link mode stuff or without all the nested attribute stuff, I think, if we can avoid it. Speed megabits 1000. It's still LI for now because we're gonna have to rename it. So now this is our 10 gig interface, and then this is our 10 gig interface again, and our 1 gig interface as well. What am I doing? No, oh, never mind. Okay. Link modes get. Link modes header. Encode link mode, failed to get link mode. Unexpected link mode. Yes, we get similar things here. We can verify, we can fetch it both by index, by name, and by both parameters as well. Almost seems like there's more room to deduplicate here, actually, between the different calls. Maybe we will. A lot of this logic ends up being the same for a lot of these tests, so there probably is more room to dedupe. The problem is I don't want to parameterize too much, because if you have a test that takes like 50 different inputs, then it becomes just hard to read, you know? But I think we've struck a pretty good balance so far. And the coverage is looking quite good. Sometimes I'll even cover like things like panics if I really want to verify that something as some invariant is not broken. But in this case, I think it's probably fine, you know? We're getting there. I feel like we'll look at that in a sec. I have an idea. Yeah, I feel like we could probably rework this loop a little bit here. I have an idea. We'll try that once we get this code committed. I think we're ready to commit this actually. So go.star and star.go. ethtool. Actually, we need to amend the commit because we already have the initial client link modes. And then push it. Only 10 left. Better watch out. I'm gonna order like 6. Not for me. Not all for me. 1 for me. Because I have no self-control. It's like, oh, you only got a bunch of bottles of whiskey. You only need 1 more, right? And then 1 more becomes 10 more, and that's just kind of the way that goes, you know? Ooh, something proposal, go to, meeting minutes. Yeah, nothing. Okay, nothing of note really. I am curious about the generics thread, like how bad that's going at the moment. Go line go. I already went through today and hid some comments from people who were not following the rules. Some of these proposals are you know, something else, but I'm sure, yeah, 69 comments. This has been open for 7 hours. Go talk somewhere else. Like, jeez. So many hidden comments. People just don't read. It's kind of frustrating, you know? It's like, I get that people are, like, fired up about this, but this has been discussed in the mailing list and stuff for, like, months. And chances are pretty good that if you actually just read the damn proposal, you'll find that your concern's already been addressed, you know? It's silly. I'm gonna... People are so stupid. Did you talk to all the language designers? They could have issues with the new IRC? Yeah. This is such a mess. I'm glad that I'm not. I'm glad that I'm not involved with like going through all this. But see, Axel has good comments. I'm actually going to read this one. Possibility of splitting off type lists and thus operators as a separate step. Yeah, the type list stuff is definitely strange. I can't say I disagree. The type list versus type parameters, they can be separated. So it's not, this doesn't seem unreasonable to me, but what a mess. What a mess. Pretty funny. Hopefully my CI build is done by now. What do we got? What? Oh shit, I forgot the Mac OS test stubs and stuff. Let's see here. So, yep, got to make sure everything builds on all the other platforms. Undefined link modes on 19. Ah, there we go. And others. That shouldn't take too long, I don't think. Yeah, I don't think today's gonna be like a crazy long stream. We're already at 2.5 hours. Might go like maybe another half hour or something, but we'll be streaming on Friday as well, so we can always get more done. But I think we done pretty good tonight. You know, we had some progress. We got the link mode stuff done, I think, or pretty close. I think that there are more fields we should need to look at too, but let's take a look at that actually. Yeah, so the duplex, the master slave port modes. I don't even know anything about this, honestly. Duplex. Duplex must be a constant, I would assume. Or a constant list. Link modes duplex. Let's take a look at this. This might be really easy to add. If it's just a U8. Parts link modes, right? So, case Unix ethtool. Oh, didn't I just copy that? I did. Line duplex is a uint8, right? One 255 1. Okay, so this must be a constant somewhere. So let's look for duplexy stuff in ethtool.h, I would assume. Oh boy. Linux ethtool.h. I assume there's something in here about duplex. Yeah, duplex underscore. Half full unknown. Yep. Okay, here we go. Easy. Do the same thing here. So let's see here. Yeah. Duplex port. That was weird. A duplex is the link duplex type for a link mode structure. Duplex. I feel like having all these in the same namespace, like this unknown thing, is probably going to bite me, but I don't really want to do duplex half, duplex full, duplex unknown unless I have to. because that gets really verbose. It reads better as like ethtool half, ethtool full, stuff like that, you know. So that would be my preference, would be to leave it alone. Anyway. Duplex equals int of AD uint 8. Actually, not int, we want duplex instead. Now we need to generate strings as well. Okay. Go run min. Go. There we go. Duplex unknown, full, unknown, full. Sweet. Really easy one. And now we can write test code for that in like 2 lines, basically. I mean, AE uint 8, Unix, ethtool, A, link modes, duplex. I've got to say, this netlink or this ethtool family seems to be pretty good as far as like all the conventions and stuff. Like it really sticks to them, which I appreciate. Makes my job easier. LM duplex, right? Cool. Duplex half, duplex full, duplex full. Nice. And that should be covered already. Sweet. It was like, you know, 3 whole lines, pretty much. Start that go. One more force push. If you convert a string to N64 with %, it's adding extra zeros on the end. Are you using the right base or something? Like to specify hex or decimal or whatever else? That sounds like could be problematic. Or does the string actually have extra trailing zeros? I mean, it should be based on. For some reason, this API returns timestamp as a string. Yeah, that's a thing. I mean, like, if it's a Unix timestamp as a string, that's weird. But like, you know, otherwise, like timestamps with time zones and stuff as strings is pretty normal. You know, I tend to return Unix timestamps. Makes things easier. Yep, the epoch is a string. That's weird. Or the epic. I don't actually. We had this discussion on stream one time before too. I did not know if it was epic or epoch. I've always said like epoch, but it's just epic. I tend to get these things wrong. So, come on. Let's see here. Come on. It's taking a little bit to run the... That's weird. I guess it's already got the code. Does it have to pull... Oh, there we go. It's like, that's odd that it's taking so long. Cool, we did good. I'm going to go ahead and merge this. And we might cut stream there, I guess. I mean, I can't really think of anything else I really want to do tonight. And I don't really want to get involved with something super major unless there's like anything small I can think of. I don't know. Is there anything else I really care to do? This function has so many, there's almost a comment every line here trying to explain. That's, huh. Yeah, we could look at this. I see. I kind of want to switch this so it's like a for loop over each bit, and then it will add even modes it doesn't know about with just like a name. It doesn't a name that's unknown or something. But I think at that point I might as well just make sure I figure out the what do you call it first. I feel like I might as well like generate the list of all the structs down here or something. I don't know. Yeah, I don't really want to get into that today. I think we're probably gonna wrap stream here. It's been about 2.5 hours. We did pretty good. So we'll chill. We'll be back on Friday. Yeah, I knew tonight was gonna be shorter anyway, and I can go just hang out and stuff. What's going on? Yeah, no tech people streaming. That's sad. I want to send somebody a raid. It's been a while. But yeah, thank you all for hanging out. I appreciate it. It's been a good time. I hope you all have a nice Tuesday night. I'm gonna go chill out and probably play some Stardew Valley or something. So, alrighty. I will see you all on Friday. Probably Friday, early afternoon, US Eastern time. Like probably 2 or 3. Maybe a little later in case I can do some strings. Wow. Chores and stuff. But yeah, we'll figure it out. So, alrighty. I will see you all later. Bye now.